In this video, we are going to discuss about the even signals and the odd signals. For example, a function x is said to be even if it satisfies these following conditions: that x of t is equals to x of minus t for all value of t. So what does that mean? It means that if the reflected version of a signal is equals to this same signal, then we can say that the signal is a even signal. Similarly, for digital case, if a sequence x is said to be even if it satisfies these conditions, that x of n is equals to x of minus n for all value of n. Geometrically, the graph of even signal is asymmetric about the origin. Like if you see the following continuous time signal and the discrete time signal example, we can represent the even signal such that we can take the examples. For example, cos of t is an even signal. How? If you are taking cos of minus t, so the answer will be cos of t. Similarly, if you consider t square, so if you take t is equals to minus t, then you know the square of minus t is always positive. Similarly, the t to power 4, so if you taking t minus, then again the value of t4 is positive. So for any positive value or for any even value, you can write this as a t 2 raised to the power n, means t raised to the power 2n, and n change from 1 to up to n, capital N. So like for any value of t, if you are taking it's a minus version, like if you're taking the reflected version of any signal, the answer will be the same signal. So that type of signal, you can say that these are the even signal. Second is the odd signal. A function x is said to be odd if it satisfies these following conditions: x of t is equals to minus x of minus t. For example, if you are taking the value of the function at minus time, then it will give you the reflected version. It will not give you the same signal. It will give you the reflected version of the signal. So it means that the signal is odd signal. Similarly, a sequence x is said to be odd if it satisfies this following condition: x of n is equals to minus x of minus n for all value of n. Geometrically, the graph of an odd signal is anti-symmetric about the origin. An odd signal x must be such that x of 0 is equals to 0. And these are the examples, that sine of t. So if you take sine of minus t, it will be the reflected version. You can take sine of minus t is equals to minus of sine t. So that means that it is not equals to xt. Similarly, if you take the cube, if you take the odd values of any function t raised to the power minus t raised to the power 3, and you calculate the reflected version of that signal, it will be equals to minus t raised to the power 3. So these are the example of these odd signals. Like this is the digital signal, so you can see this signal and this signal, they are both reflected version of each other. Similarly here, so the continuous time signal, this signal and that signal, they are both the reflected version of each other. So it means that the if you are taking the value of the signal at a negative time constant, then it will give you the reflected version of that signal. So in that case, the signal is the odd signal. We also have some few points about the odd signal and the even signal. For example, if you have this cos t and you have t square and t4, so if you multiply these two signals, or you can say that the product of two or more even signal, the product of two or more even signal will be the even signal. Or you can say that the sum of two or more even signal is again the even product of two or more even signal is equals to the even signal. the sum of two or more even signal is equals to the even signal. Or you can say that the product of even number of odd signal is equals to even signal. Similarly, you can say that for the odd signal, product of the odd number of odd signal, like if you have three odd signals, so like sine t and then t cube, so the product of these three will be equals to the sine of minus t is equals to minus, t minus is minus, t cube of minus is minus, so 3 times minus. So the answer will be odd. So that is why the product of odd number of odd signal is equals to the odd signal. Or you can say that okay, the sum of the odd signal is odd, but the product of even number of odd signal is always even signal. So I hope that you understand this video. If you have any question, you can ask in the comments. If you like the video, you can press the like button and subscribe the channel for more such informative video.